Hey, in this tutorial we're going to be looking at non-algebraic functions, and we're going to start by looking at exponential functions. Okay, so exponential functions are in the form of f of x equals a to the power of x. Okay, so in this form, okay, we pass through the point 0, 1, okay, and we also pass through the point 1a. Okay, and we have a horizontal asymptote, there's the y-axis. So the x-axis when y equals 0. So that's here is what a general one looks like. Okay, where we pass through the point 0, 1 and some other point 1a. Okay, so those of you out there that are thinking through this a little bit more, so that means that if we had f of x equals 2 to the power of x, okay, then that would be a shallower curve than if we had f of x equals 3 to the power of x. Okay, because this base number here, a, okay, 1 and a match up. So if a is 2, it's going to be here. If say a was 3, it'd be steeper, and if a was 4, it'd be steeper again. Okay, if we have a c value out the front, so dilation factor, then we pass to the point 0c, and we also pass to the point 1 and ac. Okay, so again, you should realise that that is actually making us be a bit steeper, and it'll actually change where our y-intercept is. Okay, if we have a dilation factor of k up the top, so we have y equals a to the kx, okay, this passes through the point 0, 1, and also passes through the point 1 on ka. So what that does is actually stretches out this way. Okay, this c stretches us this way, this k stretches us that way. Okay, so if we put these together, say we have f of x equals c a to the kx, then we pass to the point 0c, and we also pass to the point 1 on k, a times c. Okay, and we take this a bit further again, okay, and say that we have a horizontal and a vertical translation in there. So we can say that we've got ca to the kx take d plus e. Okay, so d is going to be a horizontal translation. Again, if it's minus d, we're going to go to the left. If it was plus d, we're going to go to the right. And e is a vertical translation. So the thing to remember about e, okay, is it's going to affect this horizontal asymptote. So it's going to move the horizontal asymptote up. Okay, and to keep track of these points we were going through, they look a little bit worse now, but we now go through the point d and c plus e. And the other point that we go through is 1 on k plus d, ac plus e. So notice that in the past, okay, this first point, okay, was our y-intercept. Okay, once we put in these translations, particularly this horizontal translation of d, okay, it's no longer our y-intercept. So if we were looking at one like this, okay, we would need to actually try to find our y-intercept by letting x equals 0. And if this e was a negative, so we actually move down, you'd also need to find an x-intercept as well. Okay. We'll just flick over. Okay, so again, I just said that note, when we have a vertical translation e, then the horizontal asymptote also gets translated. So I've just got a few pictures here of what some of our basic graphs look like. So this is without our translations and those type of things. So we've got our y equals a to the x, that's our basic one that we have. Okay, we'll also put in though our y equals a to the power of negative x. It goes this way, so when our negative is associated with our x, it's a reflection in the y-axis. Okay, when we have a negative at the front, it's a reflection in our x-axis. Okay, so this one here is y equals negative a to the x. Okay, and this one here is y equals negative a to the power of negative x. Okay, we also have a special case too, which is the exponential function, okay, which is e to the x. Now, this is just a special case of y equals a to the x, and it has all the same properties. Now, e is just a special number. It's called Euler's number. Okay, and it's a rational number. It's like pi in that respect. Okay, and it models real-world situations very well. Okay, so we're just going to sketch a couple of graphs to finish off this section. Okay, so we're going to say we have y equals 2e to the x plus 1. Okay, and we need to sketch that now. Okay. So what we need to do to start off with is find our y-intercept. Okay, so that's when we let x equal 0. Okay, so when we let x equal 0, we get y equals 2e to the 0 plus 1. Anything to the power of 0 is of course 1, so we get y equals 3. Okay, we won't have an x-intercept, okay, because we've moved it up, not down. Okay, it also means though that we have a asymptote. Okay, there's been moved up by 1. Okay, so we're just going to be coming through here now, okay, at 1. Okay, and then we're going to go through the point here at 3. Okay, so when we do that, okay, we can sketch it like this. Okay, we'll have a look at another one as well, which is we need to sketch y equals 3 minus 3e to the minus x on 2. So it's going to rewrite that so it's y equals minus 3e to the minus x on 2 plus 3. Okay, so what you can see there, okay, we've got our two negatives. Okay, so it's going to be in this case here, so our general shape is going to be this way. Okay, but we've also been moved up. So this has all been moved up, so we will have an x-intercept now. Okay, so we'll find our y-intercept first. Okay, that's when we let x equal 0. Okay, so up here is all going to be 0, so this is going to be 1. Okay, so then we end up with negative 3 plus 3, so we're going to have a y-intercept of at 0, 0. If we look at our x-intercept, okay, that's when y equals 0. Okay, so what we need to do is take 3 away. Negative 3 equals negative 3e to the negative x on 2. Okay, which gives us 0 equals e to the negative x on 2. Okay, and what we'll find though, actually, we don't need to keep doing this, okay, is that we actually have our x-intercept anyway. So, doing work that we don't need to do. Okay, so sorry about that. Okay, so we were saying we've been moved up by 3, which puts us at 3, and we know we're going through 0, 0. So you can finish it off like that. Okay, and we've got one last graph that we will sketch, which is y equals negative a quarter e to the x plus 1. Okay, so for this one, we've been reflected in the x-axis, so we're still not going to have an x-intercept, but we do need to find our y-intercept, okay, which is when x equals 0. So y is going to equal negative a quarter of e to the power of 1, which we just leave as negative a quarter e. Okay, which is that's an odd part, but you just got to remember that e is a number. Okay. We haven't had a vertical translation at all. Okay, so we still have our asymptote here. Okay, we've been reflected in our x-axis, so I think instead of a graph coming like this, it's going to come like that now. And this is our negative a quarter e. And if you like, you could find another point on there as well. Okay, it's not a bad idea, just because we really should have it, because otherwise we're not really doing anything that's showing much about this this part of the graph here, our negative quarter, okay, that dilation factor. So we could pick any number. We could just put in a good one is probably negative 1, because it'll get rid of up here. Because if we put in negative 1, we get negative a quarter e to the negative 1 plus 1, which will be y equals negative a quarter e to the 0, which is just negative a quarter. So you could say here at negative 1, okay, we go through negative a quarter. Okay, so that's all I'm going to go through in this tutorial. There will be another tutorial that goes with this section about circular functions.